case of reverse bias, p-type material is connected to the negative of the battery and n-type is connected in the positive of the battery. Voltage current characteristics, when you draw the voltage current characteristics, here on the x-axis you are going to draw the voltage and on y-axis you are going to draw the current. So in the first quadrant, when the barrier potential is broken, then it is, the diode is conducting in the forward bias. And in the third quadrant, here VBR is there, that is known as the knee potential, the reverse bias will be there. Now currents in PN junction diode. An isolated junction is there, in the second diagram forward bias junction is there, and in the third the reverse bias junction is used. The current equation for the forward and reverse bias ideal diode equation is given by ID is equals to IS e to the power QVD divided by NKT minus 1. When VD is negative, ID is approximately equals to minus IS, and when VD is positive, ID is approximately equals to IS e to the power Q VD divided by NKT. Diode as a switch. Diode can be used as a switch when it is connected in the reverse bias as well as in the forward bias condition. Ideal diode model is there. Here, when p-type is connected to the positive of the battery, that is called as the forward bias, and when it is connected in the reverse bias, that is p-type is connected to the negative of the battery, the switch acts as a off switch. Diode as a rectifier. It is a circuit which converts the AC into the pulsating DC. This is called as a rectifier. There are different types of rectifier: half-wave rectifier, full-wave rectifier. Full-wave rectifier is again classified into center tapped and bridge. When you talk about the half-wave rectifier, the diode is conducting only in the positive direction of the AC power supply. Center tapped or full-wave rectifier, here the two diodes are connected. The transformer is connected at the input side. At the secondary of the transformer, the D1 and D2 are connected. Then during the positive half cycle, diode D1 will be conducting, and during the negative half cycle, diode D2 will be conducting. Also, this full-wave rectifier is classified into the bridge rectifier, where 4 diodes are used in a bridge fashion. So diode D1 and D2 will be working during the positive half cycle, and D3 and D4 will be working during the negative half cycle of the input signal. So the output you will be getting in both the half cycles. Now this is the comparison of half-wave rectifier and the full-wave rectifier. In the half-wave rectifier, number of diodes required are 1. When you talk about the center tap full-wave rectifier, diode required are 2. In the case of bridge rectifier, the number of diodes required are 4. Secondary voltage is Vm. In the case of half-wave rectifier, center tap full-wave rectifier 2 Vm, and bridge type full-wave rectifier it is Vm. DC output in the case of half-wave rectifier is Vm by pi. In the case of full-wave rectifier, it is 2 Vm by pi. Ripple factor is 1.21 in the case of half-wave rectifier. In the case of center tap, it is 0.482. Rectification efficiency is 40.6 in the case of half-wave rectifier. Full-wave rectifier 81.2, and transformer utilization factor in the case of half-wave rectifier is 0.287. In the case of full-wave rectifier, center tap 0.692, and in the case of bridge, it is 0.811. Special purpose diodes are there. Zener diode. The equivalent circuit is shown over here in the case of Zener diode. This is one of the special purpose diode which is present. Zener is always connected in the reverse bias. Features: uses the relatively constant reverse breakdown voltage to produce the output voltage reference. Breakdown voltage is called as Vz. Output voltage of the circuit is equals to Vz despite of variations in the input voltage V. A resistor is used to limit the current of the diode. These are the certain differences between the special, that is Zener diode and PN junction diode. When the PN junction diode is there, the electricity flows in one direction. In the case of Zener diode, the electricity flows in both the directions. In the case of PN junction diode, the reverse bias permanently damages the depletion region, and in the case of Zener, the reverse bias breaks the electricity flow in both the directions. The width of depletion region is large because the P and N regions is slightly low, and the width of depletion region is narrow in the case of Zener diode. This is used for rectification, PN junction diode, and in the Zener diode, it is used for the voltage regulation.